All right, hi everybody. We're going to do an activity that is called Mark and Recapture. This technique is used by ecologists to help them estimate the population size when they cannot realistically go out and count every single individual. So you would use this, say, in a lake where it's not realistic to go in and count all of the fish in the lake. So you would use this mark and recapture technique. What you're going to need is your bag of beans. So make sure you pick these up at school, and you can do this at home then. So you're going to need your bag of beans, either maybe a spoon. Spoon's not necessary. I'm not going to use a spoon today, but you can. Your data table, which is the document that's attached to the assignment, and probably a calculator. So for this simulation, the beans represent a population of turtles that live in a pond. You're going to use the capture, mark, release, recapture method to estimate the population size of turtles in your pond. This is just another way of saying that same thing up there. The marked beans are going to represent turtles that have been captured, tagged with some black paint, and then returned back to the pond. The white beans represent the turtles that have not been captured and tagged, or have not simply been tagged before we will capture them. Now, without opening the bag and counting the beans, estimate how many are in here. I'm going to say, just visually looking at this, because I have not opened or counted these yet, I'm going to say 200. 200. All right. That is step number one. Without dumping the beans out of the cup or out of the bag, visually estimate the total population of the beans in the cup. Don't count them, just write your estimate on your sheet. My estimate is 200. Now, step two, carefully mix up your beans. There we go, they're mixed up. Use a spoon or simply your hand to randomly remove a spoonful or a small handful of beans and place them on the table. If you want, you can use a plate so they don't get lost. You can do this whole thing on a plate. If you want to dump them all out onto a bowl, or if you want to dump them onto the plate, you can do that someplace where you can keep them organized. So what I'm going to do is I'm going to leave them in the bag. You get some weird beans in there, like this little guy here. You can take those out. Okay. Now, the directions say to grab a small handful of beans and put them on the table. Let's do that. Don't try to grab any particular ones, just kind of reach in there and grab a small handful. This, to me, is a small handful. Now, that was step 3. Step 4 says count the beans and then mark them on both sides with a marker or a pen. Be sure to mark the mark that you make is easy to see on the bean. So I'm going to count these first and then I will mark them. 2, 4, 42, 44. I have 44 beans here. Time to mark them. You can use whatever you got at home to mark them. Something that will be a real clear mark on them and will not rub off is the best idea. So I'm going to first try my dry erase marker here, see if this can mark them easily. Flip that over. See if this actually stays on there. This rubs off too easy. All right, I've got all my beans marked. That would probably be the longest part of the lab, is marking all of the beans. Next, I counted 44 beans. All of those numbers are going to go here, 44 all the way down. Oh, 44. I'll give you a little clue, a little heads up. If you try to grab less beans, thinking that's going to help speed up this process, it might save you some time, but your numbers are going to be a little bit off. So grabbing a good size sample size like that, I did a small handful. 44 seemed pretty good as far as this size in my hand, so that was pretty good. So what we just did was count all the beans, mark them on both sides, be sure to mark that it's easy to see, then return the beans back to the bag. These beans represent your marked population. Record this number in the number of turtles marked. So that's what I did here. 44 goes in all of these. Let's return our turtles back to the pond. There we go. Close up the bag. Now it says repeat step 3 using a spoon or your hand to randomly, without looking in the bag, randomly take out a small handful or a spoonful. What I forgot to mention there is it's important that you mix up the bag. So let's add this right here. Step 5A. Mix up the bag. Mix this bag up. Make sure our turtles get spread around in the population really good. They're ready. I got marker on my fingers. Okay, next. I'm not going to look in the bag, but I'm going to reach in and grab a small handful, thinking this is going to be about the same size. All right, so I got the same size approximately. You can see right away some of my beans have got marks on them, and some of the beans in the bags have marks on them. So here we go. Now we're going to count these. So that was step 3. Step 7, count the total number of turtles captured. This is the marked beans and the white beans, and record this in the total number of captured beans. And then count the number of recaptured turtles. These are the ones that have been marked, and then record that in your data table under the number of recaptured. So, move this out of the way. How many do I got here? 41 white beans that have not been captured before. 1, 2, 3, 4, 5, 6, 7, 8. Let's go over here. 8 beans that have been recaptured, and there was 41 not captured before. So we got 49 in total. All right, go back to our directions. It says return all the beans to the cup, and then repeat steps 6. We're going to say repeat 5A, repeat 5A through step 9. We're going to do it again for the next set. So put them back in the pond. Close up the pond. Mix them up. There we go. Reach in. Don't look. Not looking. All right, there's my population I just captured. Let's see what we got. 2, 4, 15, 14, 44 total, and how many of these have been recaptured? So that's 1, 2, 3, 4, 5, and 6. So 6 of them were recaptured. All right. Now we do it again. Don't let the turtles get out. Close it up. Mix. Reach in without looking. Looking around, not in the bag. Okay, what do we got this time? 2, 4, 8, 12, 14, 15, 16, 17. How many are recaptured? I can see there's 4 there. All right, do this some more. Two, 12, 8, 2, 3, 4. 42. And it looks like 4 of them have been recaptured. And 2, 4, 6. 6. This was 50. We'll see 10, 4, 4, 6, 4, 6, 39, and 4 of them that are recaptured. 6. And then 1, 2, 3, 4, 5, 6. 6 of these. 1, 12. 2, 4, 6, 10, 11, 12, 14, 13, 31. 41. And there's 3. Only 3 that are marked there. Now, we're on step 11. Moving on to step 11. We're going to calculate the estimated population size when we have each of these trials. If you think about this, one trial is usually not very reliable, so we're going to do this multiple times. We're going to do it 10 times to find out what our estimated population size, and then at the end we're going to sum that up and find the average for what we think it is. To do this, we're going to take the total number of turtles marked. That's 44 over here. Let's move this over a little bit. So it's 44 multiplied by the total number of captured. So then in this case it's 49. And then that divided by the total number of recaptured, and that's 8. (44) times 49 equals, divided by 8 equals 269.5. Then we do this again. We do 44 times, this time it's 44, got the same number there, divided by the number of recaptured, and that's 6. So in this case, it's going to be 44 times 44 equals, divided by 6 equals 322.7. All right, I'm going to go do this again. 44 times 28 divided by 4 equals 44 times 28 equals, divided by 4, this time it's 4, equals 308. All right, I'm not going to write the equation down anymore. I'm just going to go straight across. Okay, now we're going to take all of these and we're going to find the total of all of them. Just add them up. You could drop the decimal point if you want, just to keep it simple, which I think is what I'm going to do. Here we go. 269 plus 322 plus 308 plus 4 plus 2 equals 3,419. That's the sum. Now divide that by 10, because we had 10 trials, and our estimated population size would be 342, I'm going to say. All right, next step is to count all of the beans. Take them out of the bag and count them up. It's a lot of beans to count. So what I'm going to do is I'm going to put them in groups of 10 and count them that way, so I don't lose track. 2, 4, 6, 8, 10, 11, All right, so I've got my groups here, and as I counted them out, I put them in little groups of 10, so they're all spread around here. They may have mixed up with each other, but I can tell where the groups are. So I've got one group of 9, and the rest of these are groups of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28. So that's 27 groups of 10 and one group of 9. So that's 270 plus the 9. So I have 279 beans. The actual number is 270. My estimated population was 341. As I'm looking at some of my numbers here, I can tell you right away, like this one was definitely threw me off. And then these 400s threw me off a bit. 400 here, 400 here. But to do that, we take the average estimated population, which was 342, I'll say, and subtract that from the actual population, which is 279. Divide that by the actual population size, which is 279, and then multiply that by 100, and that will give us our percentage error. 342 minus 279 equals 63 divided by 279 equals that times 100 equals 22%. 22% off. My population estimation size was not very good. Again, some of these numbers here, like this one up here, the 600, threw everything off, I think. The rest of them were pretty close. If you look at some of these 269, 280, 264, 220, 264. Some of these were really good. Some of them were pretty far off and pushed me off. So how similar were my results to the actual population? Not very good. I was 22% of my, I guess, had a 22% error. Anything that's less than 10 would be an acceptable amount of error. So mine was pretty far off. As I think about what I could do to improve this, I would say maybe my technique of grabbing the beans from the bag wasn't very accurate. Maybe I should have spread them out more. Maybe I should have mixed them up more better, or I should have grabbed bigger chunks of beans when I was grabbing to get a better idea. You know, so you can mark down what you think, how you think you did on your estimation compared to the actual. Is it a good way to find the number of individuals in the population? Unfortunately, my example today did not seem to work very well, but hopefully it's going to work better for you. You'll get a you'll get a percent error that's less than 10%. And in many cases, this is a good technique to use. It works, and they use it in many cases. Even if it's not 100% accurate, sometimes ecologists use this method. When do you think it would be a good time to use it? Any time when there are a lot of large animals that are moving around constantly, like animals in a lake, or mice in a forest, or deer, or things like this that difficult to capture, is a good time to use it. Thank you.